Hello, my name is Jonathan Hocker, and today I will be talking about forecast and prediction at Duke Energy. Today's presentation will cover forecast analysis, risk avoidance, total quality control, Six Sigma, process analysis, and a conclusion to wrap everything we've discussed together. Duke Energy has noticed that customers in Ohio and Kentucky have been experiencing frequent outages over Q1. Between the two states, there have been 10 major outages resulting in 30 hours of downtime. These outages have affected 60% of the customers in Ohio and Kentucky. The company has identified specific power pole transformers that have been identified as faulty and have been scheduled to be replaced, but the company fears that the problem may persist into the next quarter. Ohio and Kentucky make up 15% of Duke Energy's customer base, and the issue has already caused a 0.5% customer switch, almost 7,000 customers. If the problem persists, customers who have been patient and understanding of these outages will lose their patience and start shopping for other options. The company forecasts that the 0.5% switch can increase to 3% or more if the problem isn't contained by the end of Q3. The visual on the screen displays the forecast of the customer base in Ohio and Kentucky over the next 8 quarters if the problem is not contained. It is predicted that if this issue continues, even if the frequencies are not as common, that the Ohio and Kentucky customer base can drop over 33%. This has the potential to impact other states as well, which could end up being catastrophic for Duke Energy if the source of the outage problem is not contained and taken care of. In order for Duke Energy to avoid the risk of the customer base drop in Ohio, Kentucky, and potentially other states, Duke Energy must act. A specialized team of Duke Energy employees has determined that the transformers, which are believed to be the cause of the problem, are all a specific model. The team is able to do a diagnostic test to verify if the transformer is faulty or not. However, Duke Energy has been using this model in multiple states for years. The team believes the best course of action is to test each transformer of this model type to ensure that there is no risk of faulty transformers out in the environment. This path is safe but will cost more money compared to only worrying about transformers in Ohio and Kentucky. The second option runs the risk of having the issue pop up in other states. Alternatively, the company could only worry about the confirmed transformers, replace them, and then move forward. There is great risk going down this path. The team has constructed a risk chart on the screen that gives guidance on the upfront cost of each path, the expected monetary value of the path, and the 3 potential outcomes, which are no issues, moderate issues, and extensive issues, along with the probability of those occurring and their associated costs. The constructed risk chart on the screen is worth noting, as Duke Energy does not gain any money in these situations but can substantially save money in certain scenarios. If there are no issues, the cost for all 3 paths is $25,000 for routine maintenance after the initial cost. However, with moderate and extensive issues, it could cost Duke Energy up to $15 million, and then that does not include any additional losses for customer base shrinkage. While the upfront cost of checking all affected is greater than the other options, this option is best for Duke Energy to right the ship and continue on. By going this route, the company can potentially save up to $11.5 million from the transformers alone. Duke Energy should take this large financial hit up front and rely on the 95% forecast of no issues rather than spending less and leaving finances up to a gamble. In order for Duke Energy to avoid this issue again, quality control must be improved. This total quality management movement, which includes quality control, will lead to decreased costs due to less reworking, fewer mistakes, fewer delays, and better use of time and materials. W. Edwards Deming developed 14 points that a company can establish that, when followed, can lead to improved total quality control. The 14 points are displayed on the visual on the screen. Duke Energy must establish the drive for change, adopt the philosophy from top executives to field workers for high quality control, create path for switch to in-process inspection. They must give contracts to vendors with the best product, not the cheapest. The company must perform routine maintenance quality checks on products, train all employees of all levels on the new standards. Higher management will need to buy in and lead by example for full buy-in of other employees. They must also focus on ensuring total quality management instead of pressuring employees to achieve quotas. Duke Energy must allow for the expression of ideas by all employees for growth. Departments must work together to verify processes are accurate. Retraining on processes for refresh on proper guidelines, and any new changes must occur frequently. The company must verify that employees feel a part of the process and understand their role in the grand scheme of things. Finally, Duke Energy must eliminate any slogans and use actions instead of words, and of course they must push forward and take on the plan by actually acting on it rather than just planning for it. In addition to the 14 points, there are 8 major aspects of total quality control, which are displayed on the screen now. These integrate with the 14 points and work together to achieve a goal. In addition to Demon's 14 points, Six Sigma is another approach to total quality management that has become popular. It focuses on customers and has the potential to achieve quality management through reduction of variation in processes. The process includes defining projects that can be completed in a short time frame with financial information to determine a root cause. At the end, a Sigma level will be used to establish the quality attained and measure the success of the project. The end goal when using Six Sigma is that all products are within 99.99966% of specifications to avoid defective products going out into the live environment. Six Sigma is implemented into Duke Energy through the use of the DMAC system, which stands for Define, Measure, Analyze, Improve, and Control. Duke Energy has defined that the problem is the transformers out in the Ohio and Kentucky environment. Variable identification will be affected transformers and similar models to it. Duke Energy will analyze data collected to perform rigorous analysis to uncover root causes to discover the issue. From there, Duke Energy will improve upon to find the solution, improve performance, and do right by the customers. Duke Energy will then control the situation by making sure the quality and standards are top-notch to avoid this issue again. The visual on the screen displays the entire process. The Ohio and Kentucky transformer issue has been a large setback for Duke Energy, but also serves as a wake-up call for constant improvement of processes. Even when a process has been established and is up to date, it will not be over time, and Duke Energy must assemble teams to look over processes to update them occasionally. The visual shown on the screen is the suggested process flow diagram that showcases improvement on how processes will work. This new process will help Duke Energy thrive. Once a vendor is selected for a product, or if it ends up being in-house at Duke Energy, a 12-step process will take place. The main advantages of this process include training for all employees on the standards, with retraining so employees are all on the same page and trained properly. Routine maintenance of products that include in-process quality control during manufacturing and after-process quality control with quarterly checkups, and a push to always improve the process even further. As this fourth and final presentation on Duke Energy comes to a close, there has been a lot that has been discussed. The market analysis presentation focused on Duke Energy as a company. Potential states that the company could expand to and provide products and services to were discussed. This include a push for renewable energy solutions. Diagrams and explanations on how Duke Energy will market to these potential expansion areas was presented that showcased the beginning to end process. Comparison of electrical bills and cost per kilowatt per hour presented how Duke Energy stacks up to other utility companies and how much customers pay compared to other states. Finally, a targeted area analysis on the potential states of expansion, which were North Florida, Georgia, and East Tennessee, developed the idea of how much Duke Energy would grow over time. The Bayesian analysis presentation was the effect of the market analysis presentation. Duke Energy pushed forward and focused on expanding to the rest of North Florida that the company did not occupy. Promotional events was established to be held at TIAA Bank Field in association with the Jacksonville Jaguars. The Duval County area was a primary target for Duke Energy, and the probability of sampled attendance data determined how likely someone of a specific gender or age range was to win one of the many prizes that Duke Energy was offering to those who attended the event. In a turn of events, a special prize was added for one person to win a trip to Hawaii, and Duke Energy discussed ways to make sure that everyone in the contestant pool had an equal chance to win. At the event, Duke Energy received feedback from residents of Duval County on what they want out of their utility company, and statistics were applied to find specific probabilities and give the company an idea of how to reach out to these potential customers. By the end, it was recommended to executives that Duke Energy expand throughout the counties of North Florida it did not have a presence in. The decision-making presentation focused on how Duke Energy needed to make choices for the company to expand as planned. It was presented that the company would attain over 500,000 new customers in North Florida by 2023, but discussed the losses that would occur if customer demands were not met. The long-term strategy for the company and how the employees fit into that were brought up. The evaluation system of employees and structures was mentioned to provide more rigorous and frequent evaluations to ensure that companies at Duke Energy are being held to a high standard. As a result, an analysis of operations at Duke Energy was conducted, and a three-step process on improving operations and procedures was created. These operations and procedures cannot be put into full effect without financial backing. A look into how Duke Energy will handle any cash flow problems was shown, and included how the company plans to gain backing for capital development. Target goals for sales over the next decade were created, focused on renewable energy diversity and electric generation diversity growth. To achieve these goals, a new solar energy product was submitted with an analysis of the risk of the project. In the end, a solar project installation in Texas was recommended to the company. This final presentation on forecast and prediction highlighted a major issue that Duke Energy can face the effects of over time. A forecast projection of the customer base in Ohio and Kentucky over the next 8 quarters was shown on the loss facing Duke Energy if the problem is not resolved. Transformers causing the frequent outages has been identified, and the company wanted to avoid as much risk as possible. As a result, they will be checking all affected models of the transformers in all the states to make sure that everything is accounted for. In addition to the recommendation, an overhaul of quality control in Duke Energy has been brought up, utilizing Demon's 14 points and Six Sigma. Diagrams for both of these methods were generated and will be used to ensure a major issue like this will never occur again. Before everything was wrapped up, a diagram on a new process flow was displayed and the advantages were discussed. Thank you for your time, and I hope you've enjoyed.